Hello, I'm Chuck Martin, and this is the Voices of the Internet of Things. With me today is Xiaodi Hou, founder and CEO of Bot Auto, which has successfully completed its first humanless hub-to-hub validation run in Houston, Texas. Xiaodi has been a pioneer in autonomous trucking. He is an internationally renowned expert in autonomous vehicles, artificial intelligence, machine learning, and computer vision. At Bot Auto, he is literally dealing with driving the future. Welcome here, Xiaodi.
Thank you for having me, Chuck.
To start, can you let our listeners know tell us what Bot Auto is. I mean, I know what it is obviously, but can you describe it?
Sure, yeah. Bot Auto is a company that builds autonomous driving technology. But there are a lot of other autonomous driving companies there. What is different about Bot Auto? Bot Auto is a trucking fleet. We operate the technology that we build, and we provide services to the shippers and 3PLs.
So you're not really looking at basically drivers. You're looking at humanless trucks.
Yes, we are focusing on level 4 autonomous driving, which by definition is humanless.
And how does the public react to that?
I think the public reaction is always thinking this is a new technology, a lot of excitement with some reservation and some sci-fi type of fear, of course, like every other technology.
So why are you doing this? You've been doing this for a while.
Yeah, it's about 10 years I've been doing this. I think autonomous trucking is really representing a very bright future of humanity, where we human are actually focusing on a lot of things on our daily life. But one thing that has been overlooked is that the transportation logistics, that part of the world is very underappreciated, and people can think about robo taxis or flying cars all the time, but they don't even know that it requires logistics for their pizza to be delivered.
So how did you do this in 2 years? I mean, that's extraordinary.
Of course, yeah, I would say that Bot Auto starts doing autonomous driving with a laser focus on reducing the cost per mile and building the level 4 system for ourselves. And we take charge of the operation of the system as well. So there are several things that are helping each other. And in the end, we got a lightning fast development speed. One is that we focus a lot on the operation efficiency, because once the operation efficiency is not high, we're actually, if thinking in a parallel universe, if we're treating this thing as a scientific experiment, in the end, what we will be able to build is a rocket, basically a rocket that will launch after everything is prepared. But instead, we're not really here to build a rocket. We're here to build a civil airplane that will haul the passengers from A to B, like in a daily job. By doing that, we actually hone our operation efficiency much better than many of our competitors. That's one. And the second is that we focus on the level 4 trucking, meaning that we don't think about taking another branch of the technology and focusing on the robotaxi, or thinking about level 2 assisted driving in addition to level 4 driving. We're laser focused. We have one goal and only one goal. That is level 4 autonomous trucking. So that's the second. And also there's the third one. The world has changed as well. As you know, 2023, ChatGPT has invented and surprised the entire world. And I, as the technologist, also take a step back and thinking about, okay, this new technology is here. There must be something special about this new era of AI. And the team has been with me thinking a lot about how can we innovate in a more aggressive way using the new age of artificial intelligence. And with that, the development speed of our system has been increased a lot compared to the technology a decade ago.
You have a real background in artificial intelligence before it was really known, or before it became cool. How does that fit in physical trucking?
In order to build the system into physical trucking, it's really like we need to build the eyes and the brain of the computer and also the muscle of the trucking. So we have a lot of cameras and LiDAR, which literally emits lasers, and using laser pulses to detect speed, or detect the distance of the things ahead of us. And also we use radar. So cameras and LiDARs and radars as the eyes and ears of the autonomous driving system. And that thing has been transmitted to a central computer. We use a lot of deep learning and other technologies. We try to comprehend the world and it recreates the world that we see. Of course, it's a 360-degree view of everything surrounds the truck. And then after seeing the world, the computer think and decides on, okay, what will be the best trajectory for the trucks to go so that on one hand, we are compliant with the traffic rules. On the second hand, we are guaranteeing safety. And on the third hand, we try to optimize the fuel efficiency and all the other auxiliary metrics. So by having all of the things being considered, we get the best trajectory. And then we execute the trajectory by sending the computer signals to the steering unit and braking unit and engine unit of the truck. So the truck rolls by itself.
Some of the autonomous vehicle companies, as you know, what they've done is they've sent their vehicles early to train on routes and all of that. It sounds like you're bypassing that using technology. Is that correct?
No, we do a lot of data collections, especially in the first year of the company. The company starts by having a data collection vehicle, and with that, we started to build the system with, of course, a combination of realistic and simulated data. And the result of that will be a system that could be able to test on the road. And certainly we have a long period of testing on the road with a human safety driver in our fleet for each truck. And only recently, a couple months ago, we started to launch the first humanless driver outrun.
Can you talk a little bit more about cost per mile? That's a really great stat that not everybody looks at, but it's reality for trucking. Where do you see that going over time?
I think we are really in the early stage of this cost per mile type of metric, because you may or may not know this. Probably 10 years ago, the entire autonomous driving industry were cleaning on one metric called miles per intervention or miles per disengagement. That is a very well-known and a well-criticized metric because human will always disengage the vehicle no matter how, because I always, when I'm riding on the Uber car, I always feel that Uber car is not safe. I would probably do something differently, but not all of those behaviors are unsafe or incorrect. And that creates a lot of noise into the MPI. On the other hand, the company has their discretion of dismissing some of the intervention or disengagement of human because there is no clear standard. Because of the lack of standard, the MPI has been heavily polluted. Today, I think it's a common sense that in the industry, people don't really look at the MPI, miles per intervention. But instead, we need a new metric. And I think for autonomous driving, many of the companies have surpassed the level of humanless, becoming, testing in a public road without a human driver. Many companies can do that. So the result of this is that we need a new metric. And the new metric should not be something that describes the technology, but should be something that describes the commercialization of this new technology. And I think cost per mile will be a natural consequence. Not only me, many other Wall Street analysts are also advocating for this cost per mile metric. And the Boston Consulting Group has issued a white paper about cost per mile. I think this is one metric that leads to the commercial readiness of an autonomous driving company. In a very similar way, just right after the oil crisis, people are talking about MPG, miles per gallon. And I think for autonomous driving, something like MPG should be here. That is cost per mile.
Does the cost per mile have to basically match or be lower than the cost of having a physical driver before it then becomes a business?
Well, I think, for operating an autonomous driving company, some companies are selling technology to the others. But in total, the provider of technology and the users of the technology, combined cost of these two parties should be lower than that of a human. Otherwise, we lose the point of removing the human driver.
Right. Plus, there's a shortage of drivers.
Yes.
So has large language, you mentioned ChatGPT, has large language models basically changed the whole dynamics of the speed of development?
Not really large language model. I think ChatGPT, you know what chat stands for is chat, but the GPT stands for generative pre-trained transformers. So there are two things, pre-trained transformers. And these are the two insights that we gather. We certainly use transformers for training ours, for doing the deep learning. And also we use the pre-trained techniques. So this is the kind of I would say that is one of the biggest inspiration from ChatGPT, that a lot of the deep learning training does not really need you to manually annotate the data. and send it to deep learning. They can just train the data by themselves by watching the continuous video and by synthesizing data and then send it to the deep learning to train. So this training process fundamentally evolved to a new era where we can afford much larger neural networks and much cheaper training cost.
Excellent. Can you talk about the test, the 40-mile test run? Anybody, by the way, who's watching this should go Google the video on that. The video is amazing to watch because the entire thing is it's with cameras everywhere. Can you describe what that test was and what the result was?
Sure, yeah. So we consider autonomous driving not only as a deep learning or an algorithmic achievement, it's actually a system engineering process. This is a system engineering project. And for every system engineering project, there is a so-called verification and validation process. It's called V&V process. You go from defining the project and you go all the way to the nitty-gritty level of the details, and then you go back to the system level and all inclusive testing, like a component testing to the system testing validation. So this V&V process is a thing that we need to do before we launch the vehicle on public roads. And of course, before launching the vehicle, there's a lot of paperwork that we need to do. And we also voluntarily submitted all of this paperwork to the authorities from Texas DOT and the federal DOT, just to give everyone a heads up that we are ready and we will launch this program. And they all are aware of this. And in addition, we even have the first responder guide and communicated with the local first responders. Like in cases where the vehicle is parked at the roadside and nobody in the vehicle, there's a little locker you can open and call us. So this type of instructions will all get prepared. And of course, the vehicle has went through multiple track tests, closed loop track tests, where we test something like very serious, like turning off one of the components on the fly, making sure that even one of the two computers, which is redundant to each other, one of the two computers fail, the other computer can still gently pull over to the side of the road. And of course, we did also a lot of driver in tests. And finally, when everything is over, that marks the completion of our V&V process. And that at that end of the V&V process, we launched the driver out internal validation.
So there was no teleoperator in any of this, is there?
Well, I think teleoperation is very popular in robotaxi, but in robo trucks, especially we're talking about long haul, there will be a significant portion of the mileage where you don't even have cellular signal at all. And even if you have the cellular signal, we're talking about driving at 65 miles per hour. And that is something that latency will kill the system. So I would say that in terms of the design principle, we don't really rely on the remote operation or remote controlling. We have some kind of remote communication capability more for the management of the fleet purposes.
So during these tests or any tests in the future, do you have someone remotely who can monitor it if they wanted to?
Well, certainly they can monitor it because we always wanted to provide the like a cargo information to our customers. So we always monitor the system. Like we can always answer where your loads, where your freights are.
I can remember years ago, pre-internet, where train people who own train companies, they couldn't tell where a lot of the cars were until they showed up.
Wow, yeah. You see, the information, the Internet of Things really is helping everything. I think the digitization process has benefited a lot, not only for our own operation, but also making this autonomous driving trucks a more attractive product for shippers and 3PLs.
Can you talk a bit about, in terms of a broader context of the industry, of the legacy infrastructure? Because you're dealing, I mean, if every truck was a smart truck, you wouldn't have any problems. And every smart car was a smart car, there'd be no problems because they know how to deal with each other. But the human error activity on the road versus the technology that you've got, which is arguably better than a human can do. How do you deal with that, or how do you see the legacy infrastructure evolving with autonomous vehicles in general?
I think there should always be a first movement. In the past, I think the industry has tried a lot of first movement coming from other directions. Some people would say, if you assume that we have a smart road, we will have everything. Other people says, assume that every vehicle can have a beacon and send out signal to others, we will have it. But the problem for all of these attempts is that the the concentration or actually the completeness of the system is never reaching to that critical moment. By concentration, I mean, or completeness, I mean that how many roads have the IoT stuff, or how many cars are equipped with the communication devices. If the adoption is too low, like only 20% people have that, the value of this 20% is actually minimal. It's negligible. It doesn't really justify the cost of installing it on the cars. I mean, people are dreaming about 100% adoption. I think that this is very,
It's
it's like a
dreaming.
chicken. Yeah, it is about dreaming. It's really a chicken egg problem. And in order to realizing this chicken egg problem, I think another alternative path, which is an autonomous driving path, is to consider that all of these things are as is as of today. And we're trying to crack this very hard problem by making the first movement of pushing forward autonomous driving technology. And once the autonomous driving technology is there, we can actually make use of the 20% roadside infrastructure. We can make use of maybe another 10% of the vehicle who have like active communication to the autonomous driving vehicles. And that will be the proper first move of anything else in the IoT world.
Can you talk a little bit about commercialization? I know you're tied up with the door maker, which is really kind of a practical approach to this stuff as opposed to theoretical. Can you talk a little bit about that and how they look at it?
Sure. Yeah. I think one thing that I'm very proud of ourselves in Bot Auto is that we don't have the halo of a technology company. We treat ourselves as a chain restaurant, as humble as a chain restaurant business. What I mean by that is that we wanted to make money, and we wanted to make sustainable money and creating value out of it. Of course, what is the value for autonomous driving in the very end? Three things. One, the driver removal value divided by or minus the operating cost, minus the customer acquisition cost. Three components. Many people consider the customer acquisition cost as negligible. While we have this cool technology, everybody should buy it. But if you're only selling a technology instead of selling a service to the others, how can an average trucking company utilize your technology? No one could utilize the technology, but probably only one or two very top level big fleet with a superior IT support. Maybe they can try it, but still, I don't really see the mass deployment of today's autonomous driving technology. But on the other hand, what we do is that we have a very direct way. We are a trucking fleet. You don't need to know. Our customers, they don't need to know whether this is driven by human or driving by autonomy or even driving by my dog. They just need to pay the service as if we're a human fleet. And I think this is a way where autonomous driving can truly penetrate into this logistics world.
When people see one of these things, can they see that there's no driver in it?
Well, if you really look into it, you can actually see there's no driver in it. I mean, I really wish that we can have smaller and like non-salient sensor suite, but today we do have some pretty salient sensor suite that is out there. People can immediately tell this is an autonomous driving vehicle. But whether it has a testing driver or not having a testing driver, you gotta squint into the driver's seat to see.
So do you think from a consumer standpoint, when they see these things, they think they're just going to be curious?
Yes, I think it is. I mean, it looks a little bit futuristic, I would say, from the exterior.
So a year from now, we're sitting here having this conversation. What will we be talking about?
Okay, I think a year from now, I will be talking about numbers. I'll become a number guy. Even right now, I'm actually talking about numbers quite a lot. For example, today, even though we only did a very limited driver out runs, our implied driver out cost in terms of the cost per mile is already lower than that of a human.
Well, I look forward to that conversation. Thank you, Xiaodi, and thank you all for listening to the Voices of the Internet of Things. I'm Chuck Martin.
Thank you, Chuck.